Welcome to AI and Economics by Ash Stewart, Episode 08, Digitization and Dematerialization. In the last two episodes, I chronicled the rapid development of the fields of software and hardware. Let's now examine in further detail how a great many aspects of activity and production are moving from the physical, hardware world to the digital, software. Originally, a computer referred to a woman in a team who carried out computation, calculations on a large sheet of paper, spread across a table or the room, the physical spreadsheet, or switched wires, an early physical way of coding, on bulky devices, early forms of what we now call computers. And yes, these were almost always women because any form of programming or working on software, as we'd now call it, was seen as an inferior task compared to working on hardware, which the men kept for themselves. However, you can bet that nowadays almost nobody knows of this meaning of the word computer. Bizarre as this may sound, the computer itself has been digitized from a human computer to a digital computer. I have already touched upon a second iteration of this in the Hardware Revolution article. Let's examine other areas where this physical to digital transition has happened or is happening. The advent of the calculator can be seen as an early popular example of the digitization, in this case, of arithmetic. Of course, the digital calculator, a single-purpose device as hinted in the last article, has been in effect subsumed by the general-purpose computer, but it's the same idea. This then extends to wider office applications, such as word processing, remember the spreadsheet mentioned above, and related tasks, which in the past were done on flattened dead trees, i.e. paper. Closely related to this is, of course, messaging. Some of you may remember receiving memos printed by typewriters on, yes, paper, again. Or those faxes, anyone, eh? Today it's email and texts and notifications on your phone. The advent of the web, which allows you to access the internet using the browser, has extended this to a great many other areas. Who still reads newspapers and bulky shopping catalogs or train timetables printed on paper, eh? Within industry, engineering design is an important example of digitization. Large handcrafted paper-based designs of mechanical and civil engineering artifacts, for example, have been replaced by computer-aided design, CAD, allowing for a much more rapid turnaround and indeed experimentation of the design. An extension to this has been the more recent technology of 3D printing, where such designs can then be directly transformed to such a machine that prints, essentially makes the actual physical product directly. Medicine is another impactful case study. Recent advances have allowed us to move more and more activities in this field to the digital realm. Firstly, the decoding of the genome is itself a fantastic example of uncovering nature's own little digital secret, one that's made all life and evolution possible. This then has paved the way to creating representations of DNA, using our computer technologies to, for example, programmatically modify a genomic pattern to eliminate a hereditary disease. Or, more recently, machine learning has been applied to decoding protein structures, the binding element of all biological processes. And perhaps most excitingly, albeit perhaps also a bit scarily, there is the prospect of uploading one's entire mind into the cloud, into the computer, something that has often been mentioned by the futurist Ray Kurzweil, seen as a form of achieving immortality. Perhaps a more useful development in the near term, also touted by Kurzweil, is the full digital simulation of a person's physiology, paving the way for fully personalized digital testing of medication, avoiding costly and generalized clinical trials. This would make possible successful administration of medication suited precisely for your physiology, and thus far more efficacious. Within the context of digital simulation of human behavior, only in the last few days has there been growing talk of recreating LLM-based agents, mirroring personalities of individuals, which can then be used in polling, case studies, and focus groups. Digitization, as I've outlined above, is accelerating a phenomenon described as dematerialization. This is the economic phenomenon of producing more using less material. As per studies carried out by digital economist Andrew McAfee, see More from Less, Published 2019. Free market capitalism and technological progress, the prevalent economic system in industrialized nations, are leading to this ecologically beneficial phenomenon. And already in advanced countries, such as the United States and the United Kingdom, raw material consumption in many industries and in the economy as a whole has already peaked over the last decade and is now decreasing for the same or increased output and productivity. While this phenomenon might require greater assessment across the global economy, from the above outline, it's not hard to imagine how much tree cutting has been saved by the elimination or reduction of the use of paper across sectors. Similarly, this should give context to the concerns of AI and data centers consuming energy, considering the corresponding costs of the manual labor and material consumption such AI is replacing. I'll come back to this in Econ 09. A lot of what I have outlined here is before the widespread emergence of AI, machine learning, but especially the more recent generative AI. But this is an important part of the story, because as we shall continue to explore, AI has significant potential to turbocharge every such industry that has been or is being digitized and dematerialized. Thanks for listening. See you again soon.